Good afternoon from the Hoover Institution here at Stanford University in California. Good morning to our participants from Taiwan, several of them at National Tsinghua University, and good day to our audience, wherever you may be out there. I am Karis Templeman. I am a research fellow here at the Hoover Institution and the program manager of the Project on Taiwan in the Indo-Pacific region. And it's my pleasure today to introduce our event this afternoon on deepening US-Taiwan cooperation through semiconductors. I wanted to offer a couple of remarks before we jump into the two panels that we have set for today. We're going to feature a distinguished group of experts from both Taiwan and the United States to talk about US-Taiwan cooperation in the semiconductor industry and in policy towards semiconductors. And one of the goals of convening this event is to follow on a recommendation from a report that the Hoover Institution recently published called Silicon Triangle: the United States, Taiwan, China, and Global Semiconductor Security. And that recommendation was to do more with our Taiwan colleagues, both in the academic space and in the policy space. And so one motivation for convening this group today is to kind of follow on that recommendation, to actually walk the walk and engage with our partners in Taiwan on these critical issues. We, of course, also want to call our audience's attention to the publication of this new report that is the result of about 18 months of work by a working group at the Hoover Institution that included a visit to Taiwan a little over a year ago, where we met with a couple of the people involved in today's event, including Terry Tsao, who we saw last August. It's good to see you here, Terry. Second, I think it's important for our own project and our own working group to push back against some of the what I would call negative narratives, the Yimei Luan narratives about the United States as being a kind of unreliable partner in this relationship. Our own view is that the United States and Taiwan actually have a lot of room to deepen our partnership, and that we should focus both on US-Taiwan government coordination and industry cooperation, as well as academic exchanges. And so that's one message I'd like to leave our audience with today. And then the third goal of this symposium today is to allow our audience to hear Taiwanese perspectives as well on US-Taiwan cooperation. There's a tremendous amount of interest in the United States right now in Taiwan's semiconductor industry and about strengthening the US semiconductor industry. And I worry sometimes that the interests of Taiwan are too often treated as an afterthought in conversations about semiconductors. And so it's extremely valuable for us today to hear directly from our Taiwan participants about these issues too. So on that note, I'd like to turn the floor over to Ming-Chi Chen, who's an associate professor of sociology at National Tsinghua University and formerly of the Mainland Affairs Council in the Tsai administration. Ming-Chi, it's good to see you this morning. Welcome, and the floor is yours.
So thank you very much, Karis, for organizing such a great seminar, bringing together scholars and the industry experts from the Hoover Institution and the National Tsinghua University to discuss an issue of vast importance to the economic interest and the national security of Taiwan and the United States. It's an honor to be part of the effort to raise people's awareness about the prominence of the Taiwan-US PRC triangle, not only in maintaining peace and stability in the Indo-Pacific region and beyond, but also in shaping the configurations of the global supply chain for critical technologies. Although Taiwan and semiconductor has received certain attention that would rather avoid. And congratulations to the Hoover Institution for publishing this wonderful policy paper that provides timely, in-depth, and balanced analysis and sound policy advice. Particularly, this report stands out among the numerous others covering similar subject by taking into consideration Taiwan's interests and the concerns. As an economic sociologist uniting in a defense and national security think tank, I would like to highlight some of the key points in the Silicon Triangle report and add some of my own, while we discuss the way to deepening US-Taiwan cooperation through semiconductors. First, economies of agglomeration and the ecosystem matter. In more than 4 decades, Taiwan has built a world-class semiconductor industry, not through a mercantile state, a couple of well-founded chaebols, or several standalone big techs. Rather, Taiwan's strengths lie in the agglomeration of many firms, each focusing on a small segment of the whole manufacturing process, yet complementing each other to form an integrated ecosystem in which trust is essential for governing inter-firm exchange. Semiconductor manufacturing cluster in Taiwan is Taiwan's small firm network tour de force, and it is not easily replicable elsewhere. Second, trust matters. The renowned globalization theorist Thomas Friedman wrote an article earlier this year, arguing that the world has entered a new era where goods and the service crossing country borders are no longer the identical and anonymous shell of goods that have nothing to do with one's privacy or identity. Instead, these goods, including telecommunication devices, AI, apps on your smartphones, and the chip that drive all of this, account for a significant portion of inter-country exchange. Whether you can trust your smartphone has now become not only a critical personal matter, but an issue with strong national security implications. In short, trust is essential in the era of cheap goods. 3, value matters. As hyper-globalization subsists, what has reemerged is not only geopolitics, but also the values that we hold. The techno-Leninist regime has ridden the tide of globalization and turned technology into tools to repress its people and invade its neighbors. Technology are no longer neutral. They are now value-laden because who controls technologies matters a lot. Because technology are enablers, and the problem is whether they enable democratic values and the civil liberty or dictatorship. Semiconductors come into play because they are enablers of the spyware that steal, the surveillance cameras that repress, and the missile that kill. 4, alliance among like-minded partners is better than unilateral long-arm regulation. Alliance built upon trust, shared values, and the mutual respect, while unilateralism destroys them all. Just as the Sino-US tech competition, the COVID pandemic, and the war in Ukraine has shifted the business community's attention from just in time to just in case. The US has customarily wield its long-arm regulation without much consultation among like-minded partners. This has not only resulted in numerous complaints and bitter feelings among its Indo-Pacific friends, but also fostered U.S. skepticism, 以美论, in the region, where the U.S. appeared to care solely about its own business interests and the national security narrowly defined, and are not truthful about its commitment to the security of the region. It is counterproductive. The U.S. would likely benefit from communicating with its like-minded chip partners about its strategic goal, emphasizing that it does not intend to use reshoring to replace friendshoring. This strategic communication could take place in a minilateral platform composing of government officials and the industry leaders. 5, and the last, Taiwan should also amend its own legal system to strengthen the collective small yard high-fan technology regulatory regime. Due to the close ties between Taiwan and PRC's high-tech communities, Taiwan sometimes becomes a loophole for technology leakage. This hurts the partnership among like-minded countries and brings distrust. Taiwan should strengthen its legal framework concerning investment review, export control, intellectual property, and talent migration. On this regard, Taiwan can seek help from the US to synchronize the regulatory regimes of two countries. And by doing so, it qualifies itself as a trustworthy partner to a minilateral alliance of semiconductor and other critical technologies. To conclude, Taiwan's security is the security of the democratic chip supply chain. Taiwan is not only a semiconductor powerhouse, it shares democratic values, private entrepreneurship, and is a trusted partner of the free world. As Taiwan's complex cluster of chip manufacturing is not easily replicable elsewhere, I echo the view of Hoover's Silicon Triangle report that by standing with Taiwan, the US is safeguarding its own supply chains, its national interests, and most of all, our shared values. Thank you.
Thank you, Ming-Chi, for those opening remarks. We'll have a lot more to say about everything you've already put on the table, I am sure, but I find those very encouraging. I'm going to turn the floor over now to Larry Diamond, who's the principal investigator, co-principal investigator of the project on Taiwan in the Indo-Pacific region, and also one of the co-editors of Silicon Triangle. Larry?
Okay, Karis. First of all, Karis, thank you for your role in organizing this online workshop with Professor Ming-Chi Chen, and thank you both for your opening remarks, and thanks to all of our participants for joining us. I don't want to take more time by offering a long set of framing remarks, so I only want to say one thing. One of the my style is very direct and candid, so I'm going to be direct and candid. One of the dumbest and most counterproductive statements that a former American national security official ever made was the one made by a recent former national security advisor in Taiwan, who said, well, you know, if China invades Taiwan, we'll just destroy the Taiwan, the semiconductor industry in Taiwan. First of all, we need to be steadfast and also confident in making it clear that we can and will together, through the prudent management of our policies, and through the strength of our alliances and forms of cooperation, ensure peace and stability across the strait and deter any catastrophic unilateral action. And second of all, we do not view, the United States does not view, the current administration does not view, and the American people do not view Taiwan as just some kind of platform for manufacturing semiconductors and making sure that our industry has enough of them. Taiwan is a deeply and intrinsically and indispensably valued partner to the United States because of our shared values and because of our ability to cooperate to advance economic possibilities and human welfare across the board through two, I'd say, promisingly complementary economies and sets of research and technological leadership and so on. And I hope a theme that came through Silicon Triangle and will come through this webinar is the word cooperation. That is what is needed between Taiwan and the United States, and it's got many challenges involved, but many exciting possibilities. So that's my editorial. Now, it's my pleasure to kick off the first and moderate the first panel, and then my colleague, as Kara said, in our program on Taiwan and the Indo-Pacific region at Hoover, Admiral Jim Ellis, and my co-editor of this book and report will chair the second session. This session is going to probe industry views on deepening US-Taiwan cooperation, there is that word again, through semiconductors. And we're very lucky to have three extremely distinguished speakers who will each give some opening remarks. Then we'll have a little dialogue between them. Then we'll open it up for wider Q&A. Our first speaker is Terry Tsao, who is a seasoned executive and industry leader. He currently serves as the Global Chief Marketing Officer and also President of Taiwan at SEMI. In his current capacity, Mr. Tsao assumes the responsibility of directing corporate marketing strategies of SEMI, encompassing various critical areas such as strategy formulation, association operations, product marketing, and market communications. Our second speaker will be my colleague here at Stanford, the Willard R. and Inez Kerr-Bell Professor in the School of Engineering at Stanford, an indispensable contributor to our Silicon Triangle report, Philip Wong. Philip has been a professor of electrical engineering here at Stanford since 2004. And as I think many of you know, he was on leave for 2 years, I think 2018 to 2020, as Vice President of Corporate Research at TSMC. His research aims to translate discoveries in science into practical technologies. His works have contributed to advances in nanoscale science and technology, semiconductor technology, of course, solid-state devices, and electronic imaging. His present research covers a broad range of topics, including carbon electronics, 2D layered materials, wireless implantable biosensors, directed self-assembly, device modeling, brain-inspired computing, non-volatile memory, and 3D system integration. In other words, he's really on the cutting edge of many of the most exciting technologies of the future. Our third speaker will be Bernjeng Lin, who's a distinguished senior professor at National Tsinghua University, a position he has held since retiring as vice president of TSMC in 2016. He joined TSMC as a senior director in 2000 and became vice president in 2011. Prior to that, he founded and led Innovation Incorporated. From 1970 to 92, he worked at IBM, where he held various technical and managerial positions and was the first person to propose immersion lithography, a technique that eventually became viable in the 1980s. So let's hear from each of you for a certain amount of time. Mr. Cao, will begin with you, and then when the three of you have shared with us your initial thoughts, I'll come back to and expedite the conversation.
Thank you, and good afternoon, the audience and our good friends in US, and all the audience in Taipei, and of course, Bern, Philip, it's also very nice to meet you here by virtual. I am Terry. I work for Semi. This is the actually, we are the industry organization set up since 53 years ago in Silicon Valley. And of course, I'm the head of the Semi-Taiwan. We conduct lots of the industry collaboration and also the policy. So even though I'm based in Taiwan, I notified that the reason most of the, no matter the think tank or from the government policymaker who visit Taiwan, the topic gradually shift from the traditional beef, pork, potatoes. So the semiconductor become the every time conversation during their visit. Then, of course, I also want to congratulate. This is really a well-written report. Later on, we'll share with you what I think is very, or what's the part I think it's very valuable and it's to the point to tell the truth. So regarding this topic, I just want to begin to talk about from the industry perspective, the semiconductor industry between the US-Taiwan definitely is the industry independent, interdependent, and complementary. I think most of you know that actually the beginning of the Taiwan semiconductor can trace back from the 1976 when the Taiwan government, they want to identify semiconductor industry become the one of the most strategic industry in Taiwan. Actually, at the 1976, we sent out around 19 engineers from Taiwan. We go to RCA. So that was the beginning of the Taiwan semiconductor industry. We learned from the US company, and we also learned from the US semiconductor industry. And probably you also know that, of course, from the semiconductor global supply chain, based on the comparative advantage, every region, country, they have what's their best at in their semiconductor industry segment. So from system design perspective, US is one of the significant semiconductor sector. So for the most of the Taiwanese foundry device manufacturer, US actually is the largest pie and the portion for their customer market share. Some of the Taiwan foundry company, the US customer, even more than 50% or to 60%. So that shows how important from the supply chain or the customer perspective, US is a huge base for Taiwan semiconductor manufacturing industry. At the same time, on the other hand, Taiwan, because is the hub of the global semiconductor manufacturing, Taiwan spent the most of the semiconductor equipment and the material consumption even around the world, among the world. So for the past almost 10 years, decade, Taiwan is the largest, for example, semiconductor material consumption. And as you know that majority of the semiconductor equipment and the material, they are really the US supplier. So from that kind of both customer supply chain, both end, you can see from the industry supply chain perspective, this is really the complementary perspective. And also, I also want to make the point that actually the foundry business model actually is really the alleviate most of the big heavy capex investment to alleviate most of the U.S. Semiconductor company become the fabless, so they can really spend their company corporate fund to the R&D and to design to service. So I think the one of the Taiwanese company like TSMC, they say they really unleash the innovation. I think that's really good tagline to describe about by the Taiwanese, like even from the capex perspective, we really give the freedom for most of the U.S. Semiconductor company to do the design and the order service. And also at the same time, from the talent perspective, I think the both U.S. and Taiwan are also very in the semiconductors from the very complementary perspective. To be honest, I believe most of the younger generation in U.S. Of course, they study the STEM-related program, but if they have the priority or they have to choose, they are more willing to go to the design company like Google, Facebook, right? So they probably don't like to go to the factory with the night shift like rotation. So, but on the other hand, the talent from the Taiwan, the semiconductor manufacturing still the one of the prominent semiconductor industry. So for the younger generation, they are more willing to go into the manufacturing side. So I can say from the talent perspective, both the U.S. and the Taiwan, we are also complementary that kind of perspective. So I think nowadays we talk a lot of the resilience in the semiconductor supply chain. I think we from the in terms of the resilience, we talk about from the original from the offshore to the onshore. And however, because still have some limitation, we talk about the friendshoring. So in that kind of perspective, I think the Taiwan semiconductor industry also contribute a lot, even from just like Ming-Chi mentioned about from the just in case to the just in time to become the just in case. So lots of the localization manufacturing in US, we can see the Taiwanese company really participate there. So, for example, TSMC, in order to support the US made in US, they just built their new fab in Arizona to echo and to support the local resilience. And at the same time, it's also create lots of the job opportunity in the US. So I think, like Ming-Chi mentioned about, Taiwan is the trustworthy partner. So actually, the Taiwanese company also played a crucial role. Even in nowadays, the concept shift to the resilient Taiwanese company also support and in the U.S. semiconductor industry. So I also want to echo and make some point from this report. I think there are several points I really agree with that. First of all, I think when I saw the point talking about the insurance policy and the continuous support from the U.S. government is open for the all foreign investment. I think the concept is really show the good gesture for just not just only for the U.S. semiconductor company or industry, but also it showed a good gesture to the U.S. Non-U.S. Semiconductor manufacturer, such as the Taiwanese company. And also, I think lots of the conversation talk about how to enhance the data exchange information. I think this is also very important, and but also I want to make the point. I think in the semiconductor cyber security perspective, I think that's also the area for the U.S.-Taiwan semiconductor industry should put the emphasis on that. I think 3 years ago, the TSMC take the lead to build up the first semiconductor cybersecurity standard, and the year after, Intel also take the lead to set up another cybersecurity industry standard. I think that's also a very good example for the both U.S. and Taiwan semiconductor industry to enhance the further collaboration. Yeah, and also I also very like the point in this report. The Hoover Institute actually talk about definitely we need to set up the good friendly environment and the friendly business climate for the all the Taiwanese or the even the non U.S. semiconductor company in the U.S. I think the friendly environment, which also include for example the workforce or the labor union. I think recently, I think there's no secret. There are some of the issue for the Taiwanese semiconductor company when their factory construction in U.S. There are some of the conversation from the both party. I think, of course, this is just because in the beginning it's more like the culture shock or the different culture management style or experience, but definitely under the friendly business environment, I think the workforce or the labor union definitely will be the key success factor for both U.S. and Taiwan semiconductor industry. And last but not least, I want to conclude from the collaboration perspective. I think nowadays we talk about the success of the TSMC factory in U.S. I want to make the point that the success of the TSMC or the Taiwanese semiconductor supply chain in U.S. it is not only the TSMC or the Taiwanese semiconductor company. Actually, it is really the success for the U.S. and the U.S. semiconductor industry, because only when TSMC success, that will make the good showcase to the U.S. or to around the world. That means U.S. is really the good infrastructure to bring the semiconductor manufacturer to U.S. So I wish from both parties, we should, by the collective effort, to make sure the Taiwan semiconductor company, their investment success in U.S. I think they will definitely, we should treat it as a both win-win situation for the further enhance the U.S.-Taiwan semiconductor industry collaboration. Yeah, that is my remark for the first section. Thank you.
Great. Thank you, Terry. And it's difficult to overstate the importance of these investments proving successful for both sides of the relationship. Thank you very much for your calling out some of the points of our work and for your insights. Philip, over to you.
Well, yes, thank you, Larry, for the opportunity to join in this panel, and also thank you, Karis, for organizing this panel. And it's a pleasure to join my good friend Terry and Bern on this panel. Much has been said about the importance of semiconductors, and a lot of the discussions kind of started with this statement that it is as important as oil. As you know, the oil is a fossil fuel that's important for all of us. We need energy and so on. And there's a comparison being made between oil and semiconductor. However, I believe the comparison stops at the importance of both semiconductors and oil, but rather oil and semiconductor have very different characteristics. Oil never changes. Oil is in the ground for millions of years, and you can stockpile them, you can store them for millions of years, and they will never change. However, semiconductor needs to constantly renew itself and constantly advance to reveal its value. Otherwise, there is less value on semiconductors. Why do I say that? Well, you could ask yourself, would you like to use a cell phone with a chip that was 10 years old? And if you don't, then you know the value of semiconductor. The value of semiconductor is in its ability to provide more year after year, more functionality, more energy efficiency, more things you can do with the semiconductor chips. How do we constantly advance this? And that brings it to the next point I want to make in here, is that manufacturing of semiconductor and the research and development of semiconductor goes hand in hand. One cannot do manufacturing without knowing what to manufacture, and also you need to have the next generation of products to manufacture. So you need to constantly do research and development to produce the next generation of products that you can manufacture. At the same time, if you don't manufacture, you don't know where the real problems are, and you don't know what are important research and development topics are. So therefore, manufacturing and R&D goes hand in hand. And there lies the importance of international collaboration. Good research and development has always been a collaboration among different parties. And more important than that is a collaboration among many different regions, many different countries. Good research comes from collaboration across different regions and countries. In other words, knowledge knows no national or regional boundaries, and that produced the best research, and that produced the best development, and therefore it produced the best manufacturing technology. In that regard, there's a strong incentive for the US and also like-minded countries and Taiwan to collaborate, because there is a strong industrial base in manufacturing, semiconductor manufacturing in Taiwan, and also elsewhere in the world as well, not just limited to Taiwan, but also in the US and in Europe. They have very strong research and development efforts. In these two regions in here, and they have respectively strong R&D efforts and strong manufacturing efforts. And because, as I mentioned before, R&D and manufacturing goes hand in hand, it benefits everybody if one collaborates across the regions. So I'll stop by my comments in here and really emphasize the importance of making alliances and drawing upon the strength of everybody across the world in a collaborative way. Thank you.
Bernjang, over to you.
Okay, could you show my slides? Well, thank you, ladies and gentlemen, and thank you, all my friends in Taiwan and in the US. Well, I'm talking about chip peace as against chip war from Chris Miller. Well, actually, Chris Miller is not that pessimistic, but I'm taking everything at the bright side. So the next slide. Okay, thank you. Initially, the US is dominating in everything. The US people invented semiconductor and invented integrated circuits, and even Gordon Moore dictate the growth of the industry. Everything is American. However, IC has evolved into a multinational enterprise. Next slide. Well, this is stated more explicitly. It has become too complex to be promoted by a single country. And the next slide will tell us we need diversity. We need diversity in knowledge or in physics, chemistry, electrical engineering, computer science, optics, precision engineering, materials, statistics, and a lot. As the industry grows, as the technology grows, we can even find more disciplines that we need. Also, for the people who work on the industry, they have to be innovative, and some of them has to be consistent, some of them have to be innovative, some of them has to be persistent and goal-oriented, and so forth and so forth. All right. You cannot find single set of people that contain all the different talent needed for the industry. So that goes to the second slide. Okay, it has now evolved into, well, US is dominating in design, and Taiwan also is involved in the design. For imaging, we're talking about the Netherlands, we're talking about Germany, Japan. Etching is the US and Japan, deposition US, material Japan, and mass production, Taiwan, South Korea, metrology, US, Japan, and so forth. So we see a diversity and we see the interdependence. If any of this start functioning, the other people will suffer together. Okay, if you stop the imaging supply, nothing can work. Same thing, mass production, material supply, whatever. Okay, so the next slide tells us that you see initially the world was working on a complementary model. Let's say I'm assuming that to be self-independent for design, we need 50,000 people. Okay, and manufacturing 50,000 and so forth. Just make it simple. Every discipline, I named 5 disciplines: design, manufacturing, materials, equipment, and metrology. And we have a shortage of talent. What is our shortage? About 10%. That means we need 5,000 more people in design and so forth. Okay. But however, we are running into something called a self-sufficiency or a single country model. The next slide will tell us. Single country sufficiency model, SCS. If we do that, each country will need 125,000 people. I'm cutting out the 50,000 by half. So you need a critical mass of at least maybe 25,000 people in design and in manufacturing and so forth. And let's assume that there are 2 countries who desperately want to be self-sufficient. That translates to a need of 250,000 people, which is an order of magnitude higher than the complementary model. And that explains why we cannot find talents everywhere because of this unreasonable need. Okay, all of a sudden, in a very short time, we have this need and who satisfy this need, and we are getting into trouble. The next slide. Okay. is because there are two applications for semiconductor technology. One is military, of course, the other one is civilian. It's a very strong reason to worry about military, because national security, right? Nobody can ignore national security. However, it needs only a small quantity. According to Chris Miller, it's 2% of the entire semiconductor industry output. The other ones for civilian use is 98% of the quantity. Okay, so what's happened? If we want to be very secure in that 2% quantity, we're emphasizing the military, the M, and it will definitely disrupt C tremendously. The world economy will suffer tremendously, okay? However, if you emphasize C, it will help M. Why? Because the two can be separated. The semiconductor industry can evolve into very sophisticated common vehicles that can be used to improve people's life and the economy, also for military. The differentiation is that you can have some common vehicle like FPGA or some logic device, memory device, whatever. Or memory is a very clear example. Memory is a commodity type of thing. Okay, so the logic, the FPGA, and so forth can also be a great common vehicle. There, you put the design in, which US is very strong in. Put the design in, the particular design, the very outstanding design that will make your military and national security superior. Okay, but does not affect the economy of the world. Okay, so next slide. I'm drawing this as an example, which we probably all well know. Huawei was export controlled. Because of that, TSMC lost a big market, huge market. Because when their domestic product try to compete with TSMC products, they always lost because of the quality, the price, quantity, and so forth. However, now, because of export control, we're cutting off TSMC, forbidding it to sell anything that is of the advanced design to China. And because of that, a Chinese domestic company got to sell 20 million units. Oh, that's a tremendous quantity to help them improve their technology. We talk about quantity. We talk about, you need to manufacture a large quantity to know about the problems and to solve those problems. Now, all of a sudden, they don't have that problem. They don't have that opportunity. Now they have a tremendous golden opportunity to do that. So that's the lesson learned. We should learn the lesson. We should not promote the self-sufficiency model because it doesn't work in number, in reality, anything. Okay, and also we shouldn't provide opportunity for the Chinese IC manufacturers, which we're handing to them. Okay, all right, so the next slide will tell us something else about drones. Drone is now a pretty common technology. The difference, again, is in the special chips. Everybody can run a drone and can make it as a weapon. Okay, it's already shown. People can use drone as a weapon. It's cheap and difficult to defend weapons. Okay, however, I think US has the potential to make the most sophisticated, most capable drone because you can design those chips that make a difference from the other countries. And also US talented people, as Philip has pointed out, they want to do design. They enjoy design. They pick design to study in the university and so forth. You almost have to put a knife on their neck to make them study processing and so forth, right? And force them to work in processing. It's not going to make progress if someone is not interested in that. However, if you take advantage of the interest, you can continue to be dominating in design and either design or civilian designs. Okay, next one. Next slide, please. All right, we learned a lesson from Vietnam War. Initially, we spent a lot of time, a lot of resources, a lot of people's life to keep this goal, to keep half of Vietnam free. Okay? However, it didn't happen. We didn't reach that goal. But it's a blessing. Since we didn't reach that goal, we stopped sacrificing and so forth. Now we don't have to waste anybody's life or any resource and so forth. The entire Vietnam is now in, working the economy with us. Okay, so that should be a very good lesson to learn. Now another slide. Okay, now is nuclear war evil? Oh, well, Chris Miller said it's a chip war, right? Now there's also a nuclear war. Is it evil? Of course, it's an evil if you actually happened. But the fact is that it didn't happen because it's so destructive. Nobody there to use it. It become a deterrent. It's become a very effective deterrent. Okay, look at the chips. Next slide. Yeah, the chips also have enormous power. You can enable weapons, they can destroy the whole world. Well, here I emphasize selfish. If a national selfish, if a nation is selfish, it can use it to destroy the whole world. However, if we focus on the chips enabling power for civilian and for economic use, it can become a very, very effective deterrent and then assure peace. Okay, so that's why I said chip peace. Okay, let me also give you an example. Let's say if the worst case happened, that that Taiwan is taken over by PRC, okay, and they have control of the TSMC factory. So what's going to happen? They are going to block TSMC from supplying to the US. There's no way. Why? Because TSMC is so dependent on the equipment supply, the equipment purchase, equipment maintenance, on material supply, on design, and on market and so forth. Okay, you don't have to bomb TSMC. Just ask all your allies, the people in Europe, in Japan, and so forth, to stop supplying to Taiwan. That's it. That's it. Then the whole world will suffer. They will be unable to produce the chips at an economic price. But however, it will not happen because nobody wants that to happen. Even PRC itself doesn't want that to happen. So that is a very, very strong chip for the US to negotiate and to force PRC to allow TSMC to supply to the whole world. Well, they can produce a common vehicle, so as I mentioned, FPGA, and also common high performance CMOS, high performance FinFET, whatever. Then we put the design on to differentiate that from the world. Therefore, it's so that's all my comments. Thank you.
Great. Thank you very much for that. You've certainly, all three of you, given us a lot to chew on. We have a panel coming up next that focuses more on the security challenges, which you have introduced, Bern, with your concluding remarks. So probably we shouldn't probe this too much in depth, but since our other colleagues will be speaking on that panel and the four of us will not be on that panel, we should at least have a word or two on that, and then we'll move backwards to the theme of US-Taiwan cooperation. I'll just offer my own thought that if China does move against Taiwan, frankly, the semiconductor industry will be the least of Taiwan's worries. You will no longer live in a democracy. Many of the people who now lead civil society organizations, government and political parties will be in jail, in case you haven't noticed what's been happening in Hong Kong. And the remarkable miracle of an open, democratic, and free society will be crushed under the weight of a PRC neo-totalitarian state. People should have no illusion about this. Just look at what's happened in Hong Kong. In any case, Philip has also made the point in a different way about the semiconductor scenario, and that is that without the intellectual capital and the constant updating of the technology and inputs and so on, PRC would not be able to operate the industry. Let me just give each of you a chance to respond to the others of you very briefly. Terry and Philip, do you want to respond to that point or any other that Byrne has made? And Byrne, then I'll give you a chance to respond to them or to any of the other points they made, and then I'll come back to the cooperation theme. Terry, you have anything you want to reflect on or add from what your colleagues have said?
Actually, we are more from the industry perspective. So if something really happened, that is go beyond our industry can make the comment. I think lots of from the geopolitical perspective, of course, all the assessment was based on some rational decision making. So what we should do there is first of all to continue to enhance the like-minded region country to make sure we, from the strategic perspective, we help each other and build up the resilient counterpart partnership. I think earlier maybe I make more points on the Taiwan investment in US. But on the other hand, probably you will also notify. On the other hand, like a TSMC or the other Taiwanese semiconductors or device manufacturer, they also try to do their best to do the localization in Taiwan from both directions. One is for the international supply chain localized in Taiwan. So a big company, for example, U.S. company like Integris, they just have the big investment in Kaohsiung. And on the other hand, Taiwan TSMC or the other Taiwanese company, they're also looking for the Taiwan local supplier they have become more open-minded for build up the Taiwan news supply chain. So that's how I am thinking. I see from the resilient perspective, industry perspective, how what we can do is more from the industry perspective. I think we also heard from Mark Liu from TSMC. He also made the point that if that goes something not rational or goes something wrong, this is not just Taiwan. Actually, it's the disaster for entire world. Yeah.
I certainly agree with that. Philip?
Yeah, Larry, I echo your point. That's we later on we may return to the technical in part of it, but for now, let me just expand upon what Byrne just mentioned about export control. I think there are two industry trends that we need to be aware of. One is in the past, military technology was fairly well contained. For example, like nuclear arms and deep sea sonar, that kind of thing, which is very military focused and did not have a lot of broad societal commercial use. And containing those military technology can be more precisely applied than what it is today. Today, for semiconductors, it is broadly used in the commercial space, and basically anything that plugs into the electrical socket on the wall or use a battery uses a chip. So the entire world runs on semiconductors. And so advances in semiconductors are mainly led by the commercial space rather than led by the military space. So having control not only in the manufacturing, but also in R&D on the semiconductors and any kinds of control would have tremendous impact, broadly speaking, to the entire industry and as a result to the entire society. So the notion of small yacht and high fence that is being promoted in the US, in my opinion, is somewhat problematic because the small yacht is no longer small because of the broad commercial application of semiconductors. This is a very large yacht, in fact. And the fence is rather leaky because international collaboration, international supply chain makes the traffic of information and knowledge goes very broadly across. So I don't know, of course, I don't know what the answer or the alternative to export control is, but it behooves us to all think about what would be a better alternative than the export control tools that we have today.
Okay, and Bern, you want to reply to anything that's been said recently before I move on?
I agree a lot with what Philip has said. Some of what he has said has resonated between the two of us. What I mean is that the quantity and the cost. Now TSMC has done a lot of work in developing the advanced technology, but at the same time, it also had to control the cost, to also make the cost appealing to fulfill Moore's law. Okay, I think if anything happened to TSMC, first of all, the market now is smaller. It affects everybody, including a lot of US companies, the European companies, Japanese companies, and the Taiwan companies and Korean companies. The market has all of a sudden become smaller. And that slows down the progress because it's smaller quantity, less chance to explore, less motivation to do research. Okay, so I think there are two issues. One is a national security issue. The other one is an economic issue for the entire world. And those two has to be optimized together.
Great. Thank you very much. That's very well stated. So let's go back to cooperation now and the challenges we're facing in the building of these plants and how the US-Taiwan cooperation can be deepened on two fronts. First of all, we'll go in the same order. I'd like to ask you to comment on kind of where we're at in the arc of ambition to stand up these plants in Arizona and elsewhere. I think we're behind where we wanted to be. I think you, Terry, were very polite in alluding to some of the challenges we face in terms of workplace culture and so on and so forth. but if any of the three of you want to kind of as respectfully or not as you wish to address what you think the U.S. might do that would enable it to be more effective in realizing its side of the bargain of standing up effective and cost-effective manufacturing facilities in the United States. And in that regard, since we don't have a huge amount of time, I'll roll in the question of immigration as well, skilled immigration, which I'm quite passionate about, and I know my colleagues in the report are as well, and ask you if there's anything you want to reflect on or recommend in that regard. And before I turn to you, Terry, I also want to alert our audience that the Q&A function is open, and if you want to post questions, I'll do my best to convey them. Please go ahead, Terry.
Yeah. Yeah, earlier I just forgot in the report, I also actually I think it's in the insurance policy, you make the point about a realistic percentage for the onshore manufacturing. I really like the keyword realistic. Yeah, because nowadays we talk a lot about we doing the onshore, no matter it's a TSMC or the other device manufacturing. Actually, this realistic is also will circle back and also echo to like a Burning's perspective. Is there really efficiency? We put all the manufacturing back to US. What is the real so-called realistic? So actually, we talk a lot about onshoring or like a resilient, but we seldom talk about what is so-called realistic perspective. For example, how much is enough? And also, for example, of course, we probably in the recently we talk about we have some goal like from 10% to 20%, but I think that's also related to the so-called cost efficiency. Nowadays, for the national security or the defense part, I think that makes lots of the sense we doing the onshore manufacturing. But just make very simple example, like just in case majority of the manufacturing just replicate and duplicate in US, then it's not the ideal supply chain model like Bern just mentioned about it. Probably, for example, the iPhone become the double the price or triple the price, right? Nowadays, for example, 10% of the TSMC factory to US, then the cost probably TSMC can absorb, or even the customer a little bit is willing to pay a little bit more, so-called the resilient cost, right? But if we turn the huge of the manufacturing back to US, but this is not so-called realistic, and the market will have the other driving force to push back because the situation does not fitting like Berlin talk about the cost efficiency model at all. So the proper balance in the realistic way, and also have the good both in communication from Taiwan, the US. I think that is the must. And we, based on the consensus, we have the mutual like expectation. Otherwise, we don't have the consensus about the realistic goal. I think that's also make a lot of the uncertainty for the industry or the people in Taiwan, like oh, this is really, we suspect the US like an email, and that's also that kind of the question we're coming out. Yeah, I think I really like you make the point realistic. Yeah.
Yeah, and I think the percentage you mentioned, that's in the realm of what people are talking about. I just don't know anyone who's informed and connected to the industry that thinks we can onshore anything near to a majority of the manufacturing. But Philip, turn to you next.
Yeah, thank you, Larry. I would like to, instead of focusing on the issues and in front of us, I would like to focus on the opportunity going forward. Building up manufacturing around the world is a great opportunity in front of us because the world will need more semiconductors going forward and not less. So the demand for semiconductors will continue to be strong and also stronger than what it is today, because not only everything runs on semiconductors, but there will be more things running on semiconductors going forward. So that's for sure. So building up manufacturing worldwide and in the US is great. Now, one thing that if I may offer a thought is in the US, as opposed to many Asian countries and in countries in Europe, US is a very big country. We have 50 states and spread across 3 time zones. If you include Hawaii, is 6 time zones. It's very broad geographically. And in terms of the nature of semiconductor manufacturing is that there's a lot of value and efficiency derived in being able to concentrate everything in one location, in a very close proximity location, geographic region, because you need a very strong supply chain, not just the manufacturer of the chips, but also the equipment suppliers, the support of the equipment, the materials, chemicals, waste disposal. Everything has to be very close to each other to derive the efficiency that we expect of semiconductor technology. So it would be not very efficient if the US wants to build up semiconductor manufacturing in all 50 states. It doesn't make sense at all. So, but realizing that the political situation is such that everybody wants something to themselves, that is something that is a situation that we need to manage our expectation well enough to make sure that there is enough of concentration and not spread the resources around too much.
That's an immensely important point. We tried to make it maybe a little too subtly in our report. I'm glad you've made it very explicit here. A lot of this underscores the need for political management and political leadership of this issue in a democracy. Anyway, over to you, Bern.
Okay, good. Well, I think from the TSMC point of view, I think it's good to diversify and to spread out into other countries, because we have our own limitation in power, in water supply, and all those things. Okay. However, the problem is first is the manufacturing cost, and the other thing is look at our TSMC people. I know that the TSMC people are very smart, but I do not think that the US people are not as smart or smarter. Okay, so the differentiation between TSMC and US manufacturer is probably in the infrastructure. Okay, TSMC in the local infrastructure where it can optimize its operations. Okay, once you move it to the US, they are facing the US infrastructure. They have to be able to live with the US infrastructure and take advantage of it. I think the best is that we'll create 2 Intels or 2 global foundries, because they are run by smart people in the US infrastructure. Okay, so we end up to having maybe 3 manufacturers in the US. Okay, okay, that's good. It will satisfy the US desire to have local manufacturing, but it's not improving the the industry, the semiconductor industry.
Right, and probably we should add here, which we stress in the report, the imperative of addressing the enormous regulatory challenges at the national, state, and local level to expeditious construction of these plants, the burdens in terms of environmental clearance and so on and so forth. And that may also argue for geographic concentration, because you can kind of get all of this done and get buy-in from the state government in one or two or maybe at most three hubs or something like that. Anyway, we're now starting to accumulate questions. So let me pose two or three of them. Maybe each of you could make notes and answer what you will. One participant asks, so there's the issue of export controls. I'm sure we're going to come back to it in the next panel. It's just profound when you consider the national security dimensions, and it's agonizing because everything you said is true. On the other hand, why do we worry? The motivation is not really to keep the Chinese economy down. It's not worth it for that. It's to avoid losing a war to the People's Republic of China because of the technological edge they might gain, even from being a year or two faster ahead than they would otherwise be. Anyway, I won't opinionate further on that. But one participant asked, can outbound investment restriction be an alternative to export control? I'm sure we'll come to that in the next panel, but I mean, we'd welcome your views too. And obviously, some of that is happening with respect to the PRC. A second question, if the goal is to prevent China from developing, obviously, their military capability, and you think export controls are a bad idea, are there any other options? Well, one that was just proposed is outbound investment restriction. Have you got any other thoughts? And then, hello, Korshan, he asks, advanced semiconductor technology is widely used in communication and computation intensive application, which are very important for modern defense. So obviously we're back to that. Anyway, we'll surely discuss this even more in the next panel, but let's go back to each of you and have you reflect briefly on this. Terry first.
Yeah, this is really the dilemma to make the decision at all. Definitely from the national security or the advanced weapon perspective, it's not because of the economic perspective. Then we of course feel like this is a must for doing the policy like that. But the current situation is also not really make the best efficiency from the industry perspective, and even the first damage is most of the it is from the U.S. Industry or even the U.S. Semiconductor company at all. Yeah. So I think that's really the dilemma situation, how to balance the from the national security perspective, but also can facilitate the economic scale industry growth. And most of the semiconductor, even the U.S. semiconductor company, really take the China as a big revenue source. And I always heard about from the U.S. semiconductor company, their statement is like only when they have the semiconductor revenue from the China market, that really can facilitate and help for their advanced semiconductor next generation research for that. So I think that's the dilemma situation from the national security perspective and also from the industry perspective. Yeah. So that's my comment. Thank you.
Okay, Philip?
Yeah, I saw that there's a question or comment about advanced semiconductor technologies widely used in communications and computation-intensive applications, which are very important for modern defense. I couldn't agree with that more, except that in the past, those technologies were the advances of those technology were largely military use driven. Yeah, and I was talking about maybe like 20, 30 years ago. Today, advances in those technologies, namely communications and computation-intensive applications, are mainly driven by commercial use. So in other words, advances in those areas are happened or being deployed or examined or studied mostly first in the commercial space and not in the military space. I'll give you an example. Cloud computing has been around in the commercial space for a long time before the US military realized that they need to use cloud computing also. That's one prime example of commercial space leading many of the advances. For example, today in machine learning, AI, and AI hardware computation, companies like NVIDIA and AMD are leaders in this field, mostly by developing the technology but to satisfy the commercial use and not to satisfy military use. And the trickle down that we've seen before from military to commercial space has largely reversed, and namely the development or the advancement of technology in the commercial space is beginning to trickle down into military use. And Berlin illustrated an example about drones. Drones use chips, and those drones are first developed because people want to take aerial pictures for fun, and not to strike a target.
Bern?
Okay, well, again, I think in terms of computing power and all those things, every country already possesses that because of the easy availability of commercial products. Okay, so as Philip has pointed out, the military use for computing and so forth is not the most advanced anyway. So whatever you do doesn't make any difference. Now, in terms of the investment over export control, well, those are two vehicles. We definitely know that export control doesn't work. I think those things, the semiconductor technology is dependent on free economy, because you've got a whole world to chip in whatever they know best to advance the technology. So, well, then does investment violate free economy? I don't know. It's a difficult question to answer because if you don't invest, somebody else is going to invest. Okay, the whole world is big. If US doesn't invest, fine, somebody else will invest. So are you depleting the opportunity for the US investors to invest on something that has a high leverage, high potential to grow? So those are the things to trade off and to consider.
Okay, thanks. We have only about 8 minutes left before we take a break and then move on to the next session. I know that my colleague, Admiral Ellis, is listening and will probably bring us back to some of these national security related issues of export controls and, thinking about how to manage this problem from a national security angle. But let me conclude on a supply chain angle. and a cooperation angle, and pose kind of 2.5 questions. And then I'll come back to you in order again and give you each a chance to discuss them. Thomas Spitters asked, given the discussion about manufacturing site feasibility, would it be constructive on any economic and engineering level to enlist Japan first in line to help in the difficulties faced by Taiwan as presented by PRC? And I'll elaborate on that. This is the half question to ask, well, you've each noted, I think very wisely, that establishing a more secure supply chain and also building out investment from Taiwan, given that Taiwan's got probably some asymptotic limits it's approaching in terms of energy, water, as you said, just capacity to produce on that island. Where else might Taiwan be looking? It is already looking to Japan, and TSMC, I think, is starting to look to Japan. But where else might it be looking? And of course, a lot of the concern in the US is not just about jobs, it's just diversifying the sources of supply. Final thing, if you want to address it briefly, is about cooperation and R&D, and how you each spoke to it, I think, at the beginning, how we might move that along. So again, we'll go in order, Terry, Philip, and Bern to conclude.
Yeah, I think in terms of the diversification, I think Bern just mentioned, I fully agree, it's nothing bad for the Taiwanese company now become the global footprint, because always have the limitation in terms of the infrastructure, even the talent pool in Taiwan. So now the investment in US definitely the first step to enhance the US-Taiwan collaboration, but at the same time, not every Taiwanese company affordable go to US. So some of the other supply chain move just within the Asia Pacific region. They're looking for the opportunity to fulfill the diversification goal from the customer needs. So TSMC or even UMC could have the opportunity to expand in Japan, and also Southeast Asia for like Singapore as a front end, or the Malaysia as a back end. That's some of the geographic region become more and more popular within the semiconductor supply chain. And I think there's also no secret the progress in TSMC project in Japan, actually it goes very well. And the culture-wise, or I mean the manufacturing side, the culture discipline, or the willingness to take the night shift, something like that, is more fitting the semiconductor manufacturing. So diversification outside Taiwan, I think 1 week before, Morris John also made a comment. He foresee Japan and also Singapore probably have the great opportunity success besides of the US. So that's also some of the from diversification perspective I want to share with you. Thank you.
I'm an academic, so I would like to pick up your questions about R&D and collaboration in R&D. As I mentioned earlier, knowledge knows no boundary, and good research is clearly characterized by international collaboration. Now, it's particularly in the US, in the past, maybe like a few decades, maybe 2 or 3 decades, there has been a dearth of federal government support on research and development in the semiconductor space, with the underlying assumption is that semiconductor is something that is a technology that companies can take care of, and therefore the US does not need to specifically sponsor research in those space. But as you recognize now, manufacturing technology is a very important part of the R&D. And so the loss of manufacturing in the US has caused a loss of R&D capability in the semiconductor space in the US, coupled with the fact that the US has basically underinvested in semiconductor R&D, with the kind of a typical mentality in the US that basic science, fundamentals, basic science is the most important element to support, and applied science is something for industry to do. But I think that is a fallacy, because we need to value applied engineering sciences. Otherwise, we will fall behind in terms of manufacturing technology. If you look at Asian countries such as Korea and Taiwan and Singapore and so on, the government agencies, they do value a lot on applied engineering sciences. And that shows in after many decades of such support, it shows in the way they have grown their manufacturing capability. So I think going back to your question about R&D collaboration, there's a lot to be improved upon in terms of international collaboration, so that we all advance faster than before, because the demand for semiconductor will be more in the future than and not less. Second is, especially in US, we need to have this notion that we should value more applied engineering sciences in addition to basic science, of course, because without basic science, fundamental science, there will be no applied sciences, of course.
Well, thank you for articulating so crisply some what I think are some very important points in and recommendations in our report. Okay, Bern, we'll conclude with you.
Okay, well, I think, yes, indeed, applied science and basic science are important. However, I think it used to be very emphasized by the US. You know, look at the Intel, the Motorola, and a lot of semiconductor companies at that time in the US. Okay, well, even AMD was in manufacturing, and then they resort to, focus on the design part. So I think it's a little bit difficult to revive applied science again in the US because we are going against the trend. But it doesn't mean that we don't do it. So we have to give it a try. And you will also have to give the research people the right incentive, because now, is it glamorous? Okay, or is it worth a Nobel Prize and all those things? So, we really have to think through very carefully on what and how to improve the applied science interest in the US. In terms of collaboration, it doesn't mean that we cannot collaborate, because the country that's good at basic science, the vision at future products or whatever, there's no reason they cannot collaborate with a country who is looking at more realistic questions. Okay, they can help each other and look at each other's perspectives and help each other. So in terms of supply chain, I think we have evolved very naturally through free economy. And if we want to try to secure the supply chain, I think that's still the best way, by natural evolution instead of by forced development. Okay, those are my opinion.
Great. Wow. Well, we're a couple minutes past time, but you've really, all three of you, done a tremendous job of laying issues on the table, giving us a lot to think about, giving us perspectives, and in some ways highlighting, and in other ways maybe pushing back a little bit on some important themes of our report. I want to thank Terry Tsao, Philip Wong, and Bernjing Lin for kicking off this workshop so well, and just for such a vigorous discussion. I know that Jim Ellis will pick up on some of the themes of it in the next discussion. Karis, as I understand it, we now take about a 13-minute break and then resume?
That's correct. Yeah, we'll resume and kick off again at 6:45. It'll be
well. Thank you all for joining us, especially our friends and colleagues from Taiwan, but also the friends from the United States that are on the East Coast who are staying up late in order to participate in this. It's been a great conversation so far, and as Larry hinted, or he didn't hint, he stated on a number of occasions, the purpose of this panel is to examine the national security implications of the efforts that we have ongoing, and I think we've got a number of experts that can contribute, I think, in significant ways to that conversation. But in reference to the panel that preceded us, though, I don't think we should be surprised that even though we began as a premise, we were going to talk about collaboration and cooperation, that we moved into the national security domain or the security domain so quickly, because the title of the work of the group that we put together that authored the report that you've read is the Hoover Institution Asia Society Working Group on Semiconductor Security. But security is broadly defined, as you highlighted in your conversations. I mean, there are economic, there are business cases, there are practicalities, there are realities, there are dealings with labor forces and skills that are in short supply. There's all sorts of dimensions to security as it relates to semiconductors, as it does to many technologies. So I'm not surprised that we headed in that direction, and I'm going to reverse that, I think, as I start, because before I introduce my colleagues on the panel, I'd like to put a couple of framing issues out there, and many of them you all touched on in your conversations. And so if I'm repeating myself or repeating you, I apologize. First off, for those of you that I've not had the pleasure of meeting, I'm Jim Ellis. I'm a distinguished visiting fellow here at the Hoover Institution, and was one of the 3 co-editors of this report and oversaw its implementation. And along with Karis and Larry, I'm a part of the project on Taiwan and the Indo-Pacific, which Karis runs so well. But so I have a long background in technologies, in addition to the nuclear piece that appeared in my brief CV in the email. I also have 39 years in the military, a lot of technology background in terms of aerospace engineering and nuclear engineering and the like. And so I'm a technocrat. But as we focus on the technologies here today, we need to understand that there's a policy piece to this. And I think that's a lot of what was discussed in the first panel and is likely going to be a part of our security discussions here in the second panel. We had a number of contributors to our book. Not all of them agreed. Many of them had similar views to those that were expressed in the panel that Larry ran so well. We did not build this as a consensus report because we recognize that there's variability and there are ranges in all of this. But as with many things, as I'm fond of saying, there's probably 3 sides to every story. There's yours, there's mine, and then there's the truth. And so the question is, how do we identify where the truth is? Where do we set the rheostat or the vernier? And I would argue, as Larry and I have, that the first thing we need to do as part of ensuring the security of this global semiconductor ecosystem is elevate and expand the conversation. And that's a part of what we've been doing here tonight. And that needs to be done on a much larger scale, both domestically and internationally with our partners. You can't start a Hoover seminar here at Stanford without quoting George Shultz, our eminent leader, who regrettably is now no longer with us. But he was fond of saying that if you want people aboard at the landing, you have to have them aboard at the takeoff. And so as we think about how we want this to end, if we the model we want, because in reality, we're talking about crafting a new system here, or at least modifying significantly an existing system. And how we do that is going to involve and must involve all of you and all of us, and I would argue even a larger combination or collaboration. And so we need to think how to do that. The U.S., as part of the CHIPS Act, has established a number of regimes to do that, collaborative mechanisms. We need to ensure that those are expanded to include our international partners, and in meaningful and impactful ways. It's not the case, as I once worked for a commanding officer whose favorite saying was, Jim, if I want your opinion, I will give it to you. And so I don't want, we can't have a conversation that takes us in that direction, in something that is critically important for global security, not just U.S. and Taiwan national security, but global security, both economic and national security going forward. So we need to think about how we do this. And we need to understand that this is not a one and done. The CHIPS Act did some good things. There are some things in there that you kind of go, ooh, is that really the optimum situation? How do we establish a mechanism that has a continuing dialogue that allows us to do, as my engineer professor wife would tell me, this is an optimization problem. And it's not a static optimization problem, because the conditions and the circumstances in which we exist are changing continuously. So the idea that the lawmakers got it right, the CHIPS Act got it right, I think is a bit fallacious, but it involves, I think, the creation of mechanisms that bring the right people to the table, that put the candor that we heard in the first panel up front, and that we have those kinds of conversations and ultimately reach decisions that inevitably are going to be a compromise to one degree or another. The other piece that I would address is one that Philip and a number of others in the first panel raised, and that is that legacy chips matter. It's not just the high-end technology that we all like to focus on as we ratchet down the scale from 7 to 3 to, well, I don't know how much lower you can go. You're the experts on that, but there's a huge role and an interest in how much could we or should we do in the legacy regime that I think bears scrutiny as well, and all of this comes back to how we interact with China. And we've talked about the technologies. We know where the technologies are made. We've talked about ASML and the like, but these are global technologies, as you know better than anyone else, as our panelists do, and I hope many of our viewers and listeners know. When you talk about ASML's leading edge, deep ultraviolet technologies, the lenses are made in Germany, the lasers are made in San Diego. So, I mean, the idea that that's a Dutch problem or a Dutch issue is a bit fallacious as well. And so it kind of highlights the unique character of this, and the complexity of the complexity of the conversation that we hope ultimately will lead to some coherent and sustainable policies over the long term. We've talked about the national security piece very specifically, and there are some things that I think we need to consider on the national security side. I served for 39 years in that arena and understand the value of technology, and though I have to admit that sometimes technology is overhyped in some ways. As an old carrier fighter pilot, I was always waiting for that black box that was going to solve all my problems. And I think to some degree, I'm still waiting. But that's the nature of technology and the optimism that comes with it. But nonetheless, there are national security implications here, both for Taiwan and for the U.S. So what I'd like to do is, as we talk today, is in our panel is touch on the things that we can do that contributes to security. And security, as you define it, it's economic security, it's social stability, it's the fact that at the end of the day, whatever we produce, as Byrne reminded us, and a number of others did as well, as similar to what one of my colleagues in the nuclear industry told me many, many years ago. He says, Jim, you got to remember, nuclear is not a religion, it's a business. And at the end of the day, we have to make money at this. And whatever we decide has to be a system that is sustainable. It has to attract, as you talked about in the earlier panel, the capital that's going to be necessary. It's got to have the investors that make it all work. And so the idea that we can somehow subsidize our way out of this challenge is, I think, equally fallacious. And so it's up to us to look at the issues that need to be put on the table so that we can explore what this optimization problem might look like as we begin to move forward. And so joining me on the panel is, as Karis has already mentioned, is Panji Chen, a senior professor of economics at the Taiwan School of Economics and also a professor emeritus at National Taiwan University. In addition to an extensive teaching career, he's previously served as the president of the Hoover Institute for Economic Research, a think tank specializing in economic policy studies, and also in the Taiwan government as minister for the Council for Economic Planning and Development and the National Development Council. So again, there's an economic dimension to this, and we look forward to his contributions. My next colleague is Ko Chun Ye, professor at the National Institute of Development at the National Taiwan University, which is a research center for Chinese studies, the National Taiwan University Secretary General of EU Jean Monnet, and coordinator of China Research Program in the School of Social Sciences. And please feel free to elaborate in your backgrounds if the short précis that I put together doesn't cover all of your skill sets. And then finally, we're going to be ably assisted by Karis Templeman, who is a longstanding colleague and researcher, is the instigator and the manager of the Project on Taiwan in the Indo-Pacific, and has a decade or more of research experience here, and is well regarded as a Taiwan expert, both on the political side as well as on the social side. And so, thanks, Karis, for stepping up to be a part of this conversation. So I've opened with a few comments, some of which may be provocative, but I want to emphasize the need for collaboration and consultation in this conversation and in all the conversations that are going to address this challenge going forward, and re-emphasize the need for this has to be a continuity of conversation. It's not a one and done. Nobody has the perfect answer. And even if you did, it's not going to remain perfect for long, because the environment in which you created it and for which you created the environment you created to deal with is constantly changing as well. So I'd like to begin with going to Professor Chen and invite you to begin with any opening comments that you might want to contribute to the panel and to our many listeners.
Thank you, Jim, for a kind introduction. Can I have my PowerPoint? I'm very happy that the chair has highlighted that this session will be on national security. So some of my point probably going to coincide with what Bernardine has said already, but from a kind of different perspective. Next page, please. So the key point there is we are worried about the CHIPS Act, the real objective. There seems to be at least two objectives is put up there. One is national security, and the other is reshoring of the manufacturing industry, or try to create manufacturing employment in the U.S. And in my kind of humble opinion is that the formal objective seems to be relatively easy, although that this doesn't mean to be easy, relatively easy compared to the second objective. Okay, and so I'm going to look at the labor market conditions of the United States and Taiwan to argue that the second objective in terms of creating manufacturing jobs through reshoring of the semiconductor manufacturing would be a difficult route to go. So if we can really focus on national security, I think we will have a better solution. And then, of course, that will entail also intensive discussion, as our chair has alluded to. Next page, please. So here I just, pick up some numbers for you to take a look at how the employment profile of the TSMC in 2020 by education level. And you can see the high school graduate will account for about 13% of the total labor force, which is now about 70,000. And then your people with 2-year college is about 19.8. So altogether, you have 23% of the employment are really the people with under 4-year college education. And you have 4-year college education people, which account for about 26%. And the biggest chunk of the employment are really people with master's degree. They account for about 47% of the total. PhD is about 4%. So you put together these master's degree and PhD students, then you realize that 50% of the TSMC employment are really the guy with advanced degrees. And my message is quite simple. You cannot replicate this in the United States. It's just not possible. It's a very special labor market condition, and also the special sort of industry structure in Taiwan that allow TSMC to have this kind of privilege by sort of working with a freak of labor force which are very highly educated. And this is not also the kind of profile that you want to create jobs in the US. You know, the guys who have advanced degrees in the United States do not need the semiconductor manufacturing to provide their jobs. They have better alternative, as Berlin has just discussed. So next page. So I think that will make you clear. So this is just repeat what I say. If the US expect TSMC to create manufacturing job at high school level, I think the number will be very small, and the investment of capital will be huge, right? And then you realize that there's about 25 or 26% of the college graduate working at TSMC. These guys are primarily working on production lines. And even that was very difficult to do, to put those people to work on the production lines, and they have to take shift. So that's the kind of thing you should have really to consider. Next page. So this employment profile cannot be replicated. That's just very easy to see. The American college graduate will now work on production line, taking responsibility and doing the shift. Master degree graduate and PhDs, they may work for TSMC, but the number, I believe, will be small. And I think in the US in general, that these people with higher degree, they want to work in the software related industries, such as even in hardware industry, such as Apple, Qualcomm, NVIDIA. We classify them as a hardware company. Even in those hardware company, the people with higher degree, they are working on design, rather than production. So next page. So the availability of the skilled workers which are needed for the factory, a semiconductor factory, is really limited. And I have to read, some literatures on how Intel has trying so hard to recruit and retain lots of very limited number of skilled workers, and that's the reason they've been going to set up their factory in different places in the United States, as well as in overseas locations. So TSMC's first overseas fab, the WaferTech, which founded in 1996, is located in Commerce, Washington, just very close to Poland. And we all understand the reason for TSMC to choose that location It's because it's close to Intel and it's close to the skilled labor pool, which may be available for TSMC, but that proved to be, a failure policy. The TSMC will never compete with Intel in terms of the sort of this very skilled labor force, because they can pay better, right? The kind of product they're doing has relatively small value compared to the microprocessors that Intel has been producing. And therefore, you cannot pay a higher price, right? So if you don't pay a higher price, how would you expect to kind of lure away the workers who are working for Intel? And even if this time the Morris comment on the other day that TSMC may be different today, 20 years later, it has a higher value product being produced, and technology may be also better compared to 1996. Is that going to make TSMC more competitive in the labor market? Then I think Intel is going to suffer, right? Because this so-called really the limited pool of skilled workers available for the manufacturing industry is a key constraint we really have to think about. Next page. So, and then of course that given the problem which is already surfaced up to this point during the construction process of the Phoenix plant, you immediately realize that TSMC, if TSMC is going to succeed this time, it has to adapt to the local market labor conditions, right? It's not going to be the other way around. It has to be the company adapting to the market conditions, right? And if this TSMC does it, it will just become a second Intel. And I think this is the point that I borrow from Bird. And why, if you are going to create just a second Intel, why don't you just, provide incentive and help Intel to expand its capacity? The result will be the same, right? So you really want to create something a little bit different, or maybe the Arizona factory will be connected to Taiwan in a very strong way, such that the operation there will provide a further sort of assurance for national security. So we really think about how this Phoenix plan should be defined to serve the purpose of national security in terms of the capacity, what capacity, as already discussed in the previous panel, and also what kind of product it will be making and how this is going to be different from the power that Intel can really provide there in order to make this whole ecosystem there more sort of supportive of the national security. Next page. So that's, I think, pretty much what I have to say. The Sematech experience is history, but what the U.S. really trying to do that time was to sort of revitalize the U.S. manufacturing capability, right, to compete with Japan. And of course, that been successful to a certain extent, at least in the equipment industry. U.S. has really recovered its competitive strength. But in terms of manufacturing itself, in terms of wafer fabrication, it's really didn't do. So what happened in the end is U.S. really outsourced this manufacturing work from East Asia and concentrate on product design. And in the end, U.S. has been able to nowadays that account for about 50% of the sales in terms of semiconductor product that they design and marketing. And that gives them tremendous power, of course, in terms of dominating this geopolitics sort of rearrangement of the supply chain, because you're controlling the product you're controlling the designing, innovations, marketing of the product. And this manufacturing technology will turn out to be of secondary importance. Next page. So that's I think the history we should learn. You look at the U.S. market share in the semiconductor. In 1987, it was 37%, but today it was 49%, or close to 50%. This is calculated by the product that's sold by the U.S. company under the U.S. brand, and it's certainly designed by the U.S. company, but not necessarily manufacturing. Of course, the manufacturing sort of percentage now is falling from about 37% now to 12%. And that's we all understand this is a concern of the U.S. Policymakers, and also in the previous section, whether the decline of the manufacturing capacity or percentage is going to hurt the sort of innovative power of the U.S. industry. So that's something we could talk about. But is this 12% is not really good? Then what percentage will be really necessary? And what kind of manufacturing, as our chair also alluded to, is not necessary the cutting edge one, and maybe the legacy product are also important as well. So that's the kind of question I think we really should dig into it. Next page. So that's about, so in terms of the key technology innovation, I think we always feel that, I think Bernie also alluded to this, is probably more critical for the U.S. leadership in the industry. Next page. Okay, next page. I think because time, I will just, people can take a look. And these are the equipment industry share. The U.S. still leading with 35%, and the second with Japan. Next page. So this is the foundry part, and that's what now the concern is all about. Taiwan has about 50% share in 2021. Next page. All right, so the option, of course, here is the U.S. seems to me is no longer concerned about the mass production of the semiconductor. This was the key issue in 1986 and 87, when the U.S.-Japan trade war on semiconductor is taking place, and the Sematech was founded. So mass production, commercial product is the concern. But today seems to me is the cutting edge chips, and of course that our chair said it's probably more than that. Now the cutting edge process technology can only economically applicable with mass production, unfortunately. So you really want this cutting edge process to take place in the U.S., you need a minimum scale. Right? A too small production would not be sort of sufficient enough to support the investment and technology research needed to substantiate, to sustain that line over time, right? And of course, relocation may result in some kind of inefficiency. It's quite clear that the Arizona plant will be more expensive. So therefore, that how we're going to balance these the security issues. Next page. I think that's the final one. So the issue here is diversification seems to be something we all agree. The U.S. says that too much concentration in Taiwan is, incur some kind of risk, and diversification, as Bern just mentioned. We also need to diversify because of the resource constraints. So there seems to be a common sort of agreement there that we could diversify to a certain extent. And so if we could sort of maybe focus on that and see what the optimal strategy for diversification, then you have sort of more options available. Okay, in addition to U.S., You also have Japan, Germany, Singapore, Malaysia. They are quite obvious candidate for relocation of some manufacturing activities, right? And therefore, that they may have different advantage and therefore provide different opportunities for this. So if we kind of open up that space for policy sort of design and exercise, then I think it is a better chance for success. Thank you. That's all I have to say.
Well, thank you, Professor Chan. That was excellent and teed up a number of the issues that were both a part of our report and a part of the ongoing conversations. And like you, I've been a part of a lot of technical studies in the space domain and the cyber domain and the like, and virtually every report details that fixing K through 12 education is going to be a part of the solution. But I don't think we have the time to wait for that kind of an outcome. And you pointed out that that there are, as Ronald Reagan used to remind us, there are simple answers. There are just no easy answers, and so it's important that we understand the difference between the two. And I think that's excellent. We'll come back to your presentation here in a moment after we hear from Professor Ye. Thank you.
It's my great honor to be here, and thank you, Jim, and thank you, Harris, to invite me to be here. I would like to introduce myself a bit. In fact, I'm also the Secretary General of Chinese Association of Political Science in Taipei. Why Chinese Association in Taipei? Because it's established in 1932 in Nanjing by the nationalist government because of the Japanese invasion in Manchuria and then retreat to Taipei. In fact, we have the formal membership in International Political Science Association, which is sponsored by the United Nations. But you may wonder why China not expelled Taiwan out of the International Political Science Association, because normally political science stress on the importance of human rights and freedom. Okay, so China will not to participate at the International Political Science Association, but every year a lot of countries will question why China not here. For example, last time Italy, Greece, Brazil question why China should not be the member of the International Political Science Association, but this year in Argentina, no one questioned this. I think that this is because of the change of the geopolitical situation. Okay, so it's also closely related to the current development of these things. So, in fact, I really enjoyed the last discussion, especially the presentation by Professor Benjian Lin, Professor Byrne. He mentioned about the deterrence. Okay, the idea of the deterrence, but I agree most of his idea. But now we would like to show some historical and political viewpoints. Okay, next slide, please. I think you are familiar to this photo, right? Especially this Chinese. I think most of you know a bit Chinese. 一切反动派都是纸老虎. It means that all anti-Chinese communists and Chinese enemy are all paper tigers, including America, right? Okay, I mean, in fact, we should not forget China is very well experienced at economic and political blockade. Okay, so that's why they invented atomic bomb and satellites and missile, etc. and such. Of course, you know that semiconductor chip are smaller and more complicated. We know this, okay, but we should not forget the history. When China faced the blockade, they will try to do their best to break the blockade. Next one, please. And the next case is, Taiwanese pilots drive U-2 to recon the Chinese mainland, and the former Soviet Union donates 33 SA-2 to China, and then the U.S. intelligence say that we estimate that China ran out all of the SA-2, so it would be safer to fly into the Chinese mainland. And then this brave hero named Huang Rongbei, we should not forget this hero's name, and then shut down by the missile. And later we find that this is not SA-2, this is the red flag 1. According by reverse engineering, and this photo made by another pilot named Zhang Renliang, and from U-2. I mean, we should not underestimate China's technology and their ability to catch up the technology. Of course, I think in our last session, a professor said that how to slow down and how to stop China catch up the progress of the chip, but we should not forget about the history, and that's why next one. This is my point. China would break the blockade. Although chips are small and more complicated, okay, compared with missile or satellite. This book, published by Hoover Institution, would like to stress on the deepening US-Taiwan cooperation through semiconductor. I will show some statistics, some questionnaire statistics. Yes, of course, and I think Taiwan, according to the questionnaire, Taiwan's enterprises list in the Taiwan stock market has the ability and the will to cooperate with the United States after the trade war and this geopolitical change. For example, because I'm also the Euro-Money chair, I would like to show an example. For example, Taiwan would like to ask EU to sign the EU-Taiwan bilateral investment agreement, but it is not economic. It is too political. So EU will in fact since 2015, EU asked Taiwan to strengthen the relations through the industrial cooperation, industrial association. For example, IMEC, ESMO. In the Belgium and the Netherlands, we have a very close, very close link, very close and very real link with the Belgium and the Netherlands research institutes and the company. This is real, not symbolic. But sometimes Taiwan would like to try to get something symbolic. For example, BIA. Do you think BIA? Yeah, of course. I also fully agree the BIA, but it will be. It's not economic but political. And can semiconductor? This is my main point in this presentation. Because the theme of the book is about the semiconductor, so I would like to ask a question. Could the semiconductor be a credible threat or credible assurance to make deterrence efficient? And first, let us see the possibility of the US-Taiwan cooperation. Next one, please. For the time limitation, I just want to show the questionnaire cooperated with Chonghua Institute of Economic Research. I know Professor Chen was the dean of the CIER, and in fact, we try to ask, make the question and ask Taiwan stock market, the company list in Taiwan stock market to see whether they would like to invest in Europe and in the United States. You please focus on the right hand side. In the trade war, at the very beginning of the trade war, no one would like to invest in the United States and Europe. But after TSMC claimed that they would like to consider to invest in the United States, and then you will find that 2020 the ratio become 11. And also Europe 11. Why? Because Europe also claimed the so-called Indo-Pacific strategy. Okay, and then hesitate, decrease a little bit, but and then increase a lot because TSMC confirmed the investment in Arizona, and then they finish the investment, so the ratio decreased a little bit. Now you see the ratio also in Europe also decreased a lot because the Taiwanese company also hesitates. But now you know the almost 100% sure that TSMC would like to invest a new factory in the Sachsen, Germany. So I didn't update the number because this is from my my new chapter in a book published by the end of this year. Can semiconductor be the tool of Taiwan's economic diplomacy? If we talk about the economic diplomacy, I think this is out of question. Taiwanese enterprises would like to invest in Europe and in the United States. Next one, please. I don't want to discuss the detail, and I also fully agree Professor Chen's viewpoint. Taiwan's company would like to diversify. Okay, so you see the manufacturing sector or any semiconductor sector, the very high percentage ratio would like to develop a secondary supplier localization and the so-called short supply chain strategy. So it means that you can find a very strong willing and ability for Taiwanese enterprises to diversify in by investing in US, Europe, and other countries. Next, please. So I think if we would like to talk about the cooperation, it's not a problem. But the problem is about because this section would like to discuss about the security reason. So I would like to ask another question. And can semiconductor play a role in avoiding a war over Taiwan? And I just show a paper published on Foreign Affairs by Christensen, Glacier, and Andrew Nathan. Okay, and I like this paper because the paper mentioned Thomas Schilling, the Nobel Prize winner in economics, but I think he has a very huge impact on political science. But I think he has a very clear definition. Effective deterrence is a combination of credible threats and credible assurance. I read the book. Next one. Next slide. This is the book. I read the book. I didn't finish all of them, but I read the book. I find a lot of pages and a lot of parts mention about the role of the semiconductor in deterrence. But maybe I'm wrong. But I think the deterrence in this book means credible threats, but no credible assurance. I didn't see a lot of description about the credible assurance. So if we follow the definition by Thomas Schilling, so maybe we should think about the credible threats and credible assurance make a very effective deterrence and avoid the war in the Taiwanese cross strait. Okay, next one. So this is just some parts of the book mentioned about the deterrence. For example, the U.S. government should improve regional deterrence by partnering Taiwan manufacturing to rapid scale up local production of larger number of mobile distributed resilience weapons. This is not closely related to semiconductor, but this is the idea of the asymmetric strategies, something like that. And next page, please. And I think this page mentioned a lot. I think the main idea is about we should use the military and economic power to make a very effective deterrence. But moreover, you will see a strategy to deter China's leadership from conventional combat are not necessary, are necessary but not sufficient. Okay, so economic deterrence should be necessary. Semiconductor can offer a unique but difficult economic deterrence choice. Okay, so as Professor Benjamin and Professor Chen mentioned that we should pay a lot of cost if we would like to organize credible threats using the semiconductor industry. But how about the credible assurance? Next, please. I think in this book or other papers clearly show the semiconductors can be a credible threats. Okay, for example, you know this word by Morris Chang, Zhang Zhongmo, in CBS News say that if that person, I think that person means President Xi, right? Priority is for economic well-being, but I doubt whether his priority is economic well-being. I think they will refrain from attacking. And another paper, I think I have to say that when this paper published, it shocked a lot of Taiwanese. Okay, the broken arrow strategy. It means that when there will be a war between Taiwan in the cross strait, the semiconductor industry can be destroyed. Taiwanese semiconductor industry can be destroyed and evacuate all the human capital from Taiwan to United States. Anyway, I mean, whether you agree or not, but I think there is a lot of a description about the credible threats. But how about the credible assurance? This is the last one. Oh, please, next one. But how about, I have no clear answer, but at least I know that everything needs to change so that everything can stay at the same. If we would like to stay at the status quo, then we have to change a lot of things. For example, now US is trying to establish the new credible threats and credible assurance, and China and Taiwan need to do so too. Okay, so for example, this just example. I have no clear answer. Do you think it's possible to have a new community? For example, now the U.S. say that the three Taiwan TRA should be higher than the three community by U.S. and China, but now the problem is that U.S. It seems that the U.S. give up the strategic now the U.S. strategy become clear and clear, and China doubts whether US still support the three communique, okay, about the one China policy. Okay, so I don't know if it's possible to confirm the past assurance and also include some semiconductor part. For example, now on Tuesday, this Tuesday, US imposed a strict restriction on the equipment and chip equipment and relevant parts exporting to China. So maybe US can try to promise according to China's semiconductor development and the situation of their industrial upgrading to adjust their export control or investment control, and I don't know if it can. I don't know if semiconductor can play any role in informing the so-called credible assurance. But I have no answer. But maybe we can discuss a bit, and then we can organize credible assurance and credible threats, and semiconductor can play a very important role in this. Thank you very much. Thank you.
Thank you very much, Professor. That's extremely interesting and significant contribution, and we certainly enjoyed and learned a lot from it, particularly the historical references that with which I had some passing familiarity. But I think your points that you keyed are significant. In other words, we've got to have real, not symbolic interactions and collaboration. I'm not sure Schelling would how he would view the credible threats versus assurances, because he also said, deterrence is a combination of capability and will, and so there's a, he was a great scholar, and in fact, we're doing some work on what of his work is applicable in today's world, and we're finding, as you do, that many of those underpinning theories have great legitimacy and validity in today's world. But we did look at the silicon shield concept, though, and the status quo, and assuming that China can evaluate that on its own, and that production capability that Taiwan represents so well would deter, as Morris would hope, that deter Chinese military action. We're not sure that if Xi Jinping decides this is the time for the prosperity and the future of mainland, that the existence of the silicon industry is going to stand in his way. But again, as I said earlier, reasonable people can see that from different perspectives. Karis, could you have some thoughts here very quickly before we move to Q&A?
Since I'm batting cleanup here, I wanted to just throw a couple thoughts out about the report, and I wanted to start with a personal observation. When I started working on US-Taiwan interaction about 10 years ago, at least in a professional capacity, the Taiwanese side, so you folks, were really interested in developing deeper cooperation or ties with their US counterparts. And it was mostly a one-sided conversation. The Taiwanese side wanted to work more closely with Americans, and the American side was either silence or a kind of polite, maybe someday. And the reason was very simple: China. So academic institutions, NGOs, government agencies were reluctant to work with Taiwan because they viewed China as the big thing that they needed to prioritize. And for a variety of reasons, many of which you all know well, we're in a different world today. It's a different China, for one. We're not, in the US, we're much less enthusiastic in general about deepening cooperation with China, especially in areas that pertain to national security. It's a different US-China relationship as well. Those national security concerns are front and center. And so for Taiwan, what that means is there's a big opportunity here, and we tried to center that in our report. There's a lot of challenges that our countries face that we actually share in this new environment, and that we think Taiwan and the US could cooperate on much more. So, for instance, we have some recommendations in the report to create deeper research and development cooperation between the US and Taiwan, our research organizations, our academic institutions. We highlight a partnership between Purdue University and TSMC that got started a couple of years ago to try to train engineers and send some of them to Taiwan to get on the ground training and then come back to the US and vice versa. And our report really thought that this was a good model and something that we could scale up. Both the United States and Taiwan notably have a shortage of skilled labor. And so we both have a potential solution to that problem, immigration as well. And so there's a section in the report that touches on that too. There's a recommendation about joint evaluations of mutual semiconductor supply chain vulnerabilities and working more closely at a government to government and industry level to evaluate and share data on supply chain vulnerabilities. And then beyond just the kind of semiconductor specific questions, we also have some broader recommendations about infrastructure resilience or energy resilience. I know Taiwan has some serious energy challenges looming. The US is in a position to play a constructive role in helping Taiwan with some of those energy vulnerabilities. And the political environment in the US is much different than it was 10 years ago. And so if there's one message I could leave our audience with and our panelists with, it's there's an opportunity. We need to do more together, I think, in this new environment that we're in. And I hope that we can continue this conversation. This is beginning of a series of conversations about how we can do that, rather than having this be kind of a one and done sort of event. So with that, I'll throw it back over to the chair, and I look forward to the discussion.
Thanks, Karis. Great intervention. And I would only comment after Professor Ye's excellent presentation is that we don't have time to debate or discuss the difference between the one China policy and the one China principle, which are not at all the same, as I think we all understand. But that plays in this as well. One of the things I did want to get back though with Professor Chen, because he said a very important and interesting thing in his presentation when he said that the U.S. is in control of everything except wafer manufacturing. Does that imply, Professor, that we have more influence than we think, and that we don't need to be as alarmed about the vulnerabilities that we seem to be focused on with regard to the semiconductor situation? Could you add a bit more clarity to that?
The answer is yes. U.S. is really having more power than you think. Imagine that the U.S. is now imposing more restrictions on the semiconductor equipment, right? Exporting to China. How many of them is really manufactured in the U.S., right? You mentioned the case of ASML, which is a Dutch company, and this lithography machine was really assembled in Netherlands. But because you have key technology there's key technology coming from United States. Without that key technology, this machine would be useless. So controlling the choking point if you don't use the supply chain, maybe the technology chain, then you have the power. I think this sort of possibility or exercise in this extraterritorial rule indicate very much that U.S. is still in firm control of the entire global supply chain. So of course, I think there's a lot more room to be operated than the very, very sort of a small sort of thinking about relocating a fab back to the U.S. There must be other ways of doing that and maybe more effective. And so the question, at least I think it's very important to keep Taiwan as an important place that can continue to support this very important industry one way or the other. So that when the previous section we talk about maybe R&D collaboration in that area, in addition to manufacturing, would be very important as well, because this, if industry, if the strategy really is to be ahead of China, right? It's a moving process. You can't expect China to stand still, although you try to do everything to keep them slow. But you can imagine whatever you do, they will continue to move, right? So the most important thing is you have to move faster. And so therefore, I think the current thinking is more on containment. But I think how to advance this technology further ahead, it's also very important. And of course, that Taiwan can also contribute to that process. So I just think that we need, it is very good if that we're going to focus on national security, rather than you have multiple purposes coming from different politicians. And it's very hard to, have one law and then try to serve, 3 or 4 political objectives.
Great point. And the use of the foreign direct product rule and those types of mechanisms is actually, is obviously is an increased part of the actions that are being taken or considered as we move forward. And I think you make a good point, an excellent point, but as does Professor Ye on the need for real cooperation and collaboration. We have a couple of questions that I'd like to get to since we've had some patient participants. I think this was a bit of a softball. Do you agree that strengthening cooperation is a method for reducing risks, as every element is interconnected and launching a war requires more consideration? And then the follow-on is, do you think that the approach that's being taken by the U.S. government risks establishing 2 distinct groups in the world, one compromising democracies and the other autocracies? This kind of gets back to the greater geopolitical conversations, but I think we would all agree that strengthening cooperation is a method for reducing risk. I think that's probably a given. But what are your 2 views on the approach of the U.S. government? Do you think that's forcing a division that's unnecessary, or do you think it's acknowledging a division in societies that is inevitable going forward? I'll start with Professor Ye.
Thank you, Professor. I think, sorry, I suppose this question is for the previous section, but also very useful in this section. I think, yeah, I fully agree the cooperation, but I still need to say that a lot of things changed, but we still want to keep the so-called status quo. For example, the recent Taiwanese poll shows that almost over 80% of Taiwanese people hope that we can keep the status quo. I think maybe the people in the United States also would like to keep the current situation. But the problem is that now a lot of things has been changed. So how to establish the status quo should be a very, very big problem. For example, in 1995, we know that the American on the one hand, the 2 carrier in the Taiwanese Strait can deter Chinese military force. And on the other hand, the U.S. government said that they never advocate Taiwan independence. But the situation changed a lot. Now, the U.S. cannot just send the 2 carriers. to Taiwan Strait to deter the Chinese government threat. And it seems to me that the U.S. government also, I mean, some politicians in the Congress of the House Representative say that they advocate, they support Taiwan should be independent, or even U.S. should establish a formal diplomatic relation with Taiwan. I mean, of course, this is not related to the semiconductor, but I have to say that this is a security issue, and how to go back to the status quo under a lot of conditions changes. In fact, I think Taiwan, China, and the United States should think about this point. But now I think the U.S. strategy is very clear. For example, U.S. try to establish a lot of military bases from the Japan to the Philippines, and to change the defense strategy. But on the other hand, I don't know the U.S. government would like to do this, but sometimes some politicians visiting to Taiwan, to the former visiting in Taiwan, should not be a very good assurance for Taiwan's security, and in contrast, it will increase the risk.
Thank you.
Yeah.
No, I well understand the 1996 crisis, since I was the commander of those two aircraft carriers. So, Professor Chan, you have any perspective on the direction that these conversations can take us? Is it unnecessarily divisive? Do you see two camps? Is it going to be reglobalization without China rather than deglobalization? How do you think about the future?
Yeah, I will comment on from the economic perspective. I think this sort of division of the world into two camps, it's probably not going to happen. But it's a real thing that the China will be a strategic competitor from the U.S. point of view, right? So there was a debate about whether U.S. should decouple China from all these economic globalization in the supply chain, for example. There's debate still going on, but I think from the China perspective, it's quite clear that they have to decouple from U.S. So it's obvious the strategy going on now, that they were trying to make everything without the something will be subject to U.S. export control, right? So-called the EIA-free supply chain, or the race supply chain, you wish. So even if the U.S. were considering whether we should keep China on the supply chain, China is not going to keep U.S. on the supply chain. So that's the reality we are facing. In order to do that, of course, China would like to make friends with everybody except U.S. in terms of production. So they are approaching European Union and the other Asian countries, of course, including Taiwan, in this respect, that anybody can help them build a kind of self-sustained production system, so they can be independent from the U.S. Sort of control or coercion that is in their national interest. So we are facing this very hard reality. I really don't think the old idea, and China is so big right now on the global supply chain, no matter what you do. So apparently it's unrealistic try to decouple China, right? You just can't get them out of the whole thing. There must be some kind of strategy to keep them somewhere and maybe to exclude them from some activity. So that's a very serious issue. But the way I see this is when the Western countries, democratic societies, still debating on whether you want to decouple, but the other side is very determined already. So that's the kind of thing we are facing today. So I think the most important thing from Taiwan's viewpoint is the U.S. really need to be more humble and talk to the friends, exchange information and the more coordination, and therefore that can make the strategy work.
Oh, that's a great final thought, and I appreciate that. One of our last interveners asked the question: if we make it very difficult for China by whatever mechanisms we choose, does that not encourage them to try even harder to create these advanced capabilities? And we had that debate and discussion within the working group, and couldn't come to a consensus on that too. And here again, the answer is always it depends. And in the context in which you do that. Well, we're approaching the end here, and I know Larry and Ming-Chi Chen are still with us. Thanks for your patience in all of this, and I'd like to give them an opportunity for some closing remarks. But before I do, I want to thank certainly Karis for stepping in, but Professor Chen and Professor Ye for your excellent interventions. You've added clarity to the conversation, and you provided exactly what we were looking for, which is the academic level of examination and comment on the work that we put together over 18 months. Extremely valuable. We've decided that this has got to be a continuing effort from our perspective as well, and we certainly want to include and incorporate your perspectives as we consider options for the future. So thank you very much, and now I'll turn it back to my colleague Larry Diamond.
Well, I don't really need to say much. This has been another really excellent panel, and one thing I'd like to say is I've really learned a lot from the presentations and dialogue over the last 3 hours, and the exchange and partnership that is represented here, I think very much reflects what needs to happen at a very deep, multidimensional level between Taiwan and the United States. The operative word in this meeting, the really essential one, is cooperation, which is why I began my opening comments the way I did, because there was a certain comment made by a former public official that did not reflect the spirit of cooperation. And I've been kind of fascinated to see some of the points of convergence, not entirely, but some, between the way people in Taiwan are thinking about the future of the semiconductor industry, supply chains, Taiwan's leadership role in that, and the way the United States and others are thinking that there's a value to everybody to diversification of supply chains. I think the discussion of deterrence was very intelligent, very valuable, and we're doing a lot more work on that. I can tell you that issue of how, with a combination of strength, analytic wisdom, and information, vigilance, strength, cooperation, partnership, alliance building. You look at the world today, Ukraine, the Middle East, deterrence is just an overwhelming priority. But, if it's deterrence through provocation, it's kind of going to defeat its purpose. And I think we have some common ground there as well. So all I can say is thank you all so much. you know, Karis and I are both going to be there for the election campaign. It's our
Let's give
favorite time of
Peng
season.
Chi Chen a chance too.
Maybe we'll see some of you there. And thank you, Jim, for your just extremely adroit moderation of this session.
Peng Chi Chen, do you have any final words for us?
Nothing much beyond the deep gratitude. I work in the National Security Council, and there I also put together a group of experts and scholars, and we have a small report. And the thing that is that we want Taiwan voice to be heard. I think these panels serve that purpose well. And I think that's one thing that we have to keep in mind. That is a reality, and it's not only about, you know, Taiwan, U.S. want to decouple with China, from China. I think China, they have their own consideration about vulnerability, how to avoid the vulnerability. So that's a reality. It's not only about they decoupling from us. We decoupling from them, but they are already prepared to decouple from Taiwan. I want to echo Professor Chen's comment on that. So that's a reality. And the second thing is that very important. Here in Taiwan, we are anxious, and we don't know what's the direction of U.S. policy. I think much more consultation is needed before U.S. take any action. I think for such a long time, we've been sort of sidelined. We are informed, but not part of the conversation about the strategic goal of our alliance. So I think that is something that we should work together. And I think today's event is a beginning of that conversation, so that we can work with each other in a better way, so that we can strengthen and increase the resilience of the global supply chain of critical technology. And thank you so much for the Hoover Institution for not only publishing a wonderful report, but also hosting such a wonderful event. Thank you very much.
Thank you, sir.
Well, good night, everyone. Thank you. And we're
Good night. Good night, and welcome you all to Taiwan.
all right.
We
We'll
look
see you in
forward to it.
January.
Bye-bye.